So now we're going to look at Chapter 7, and we're looking at what's called confidence intervals and sample size. We'll have several sections that we cover, but I first want to talk about 7.1, confidence intervals. As you notice at the top of page 362, and if you notice in my book, there are a lot of things that I have marked to talk about and not talk about, and it's always good for you to go back and reread or read the parts I don't talk about. But what I do ask you to do is to take out sticky notes or highlighters, pens, pencils, maybe some index cards. But there will be a lot of words and a lot of things to think on in this section. And so you need to take time to process them. The great thing is you can hit pause and then sit there, think on it, write out a card, write it on a piece of paper, but you really need to be fully understanding what we're talking about in this 7.1 because it will set up the other sections. So it starts out by saying one aspect of inferential statistics, and then right off the bat, I've got, let's go back to pages 3 and 4. So we're going to go back to page 3. And at the very bottom of page 3, it mentions descriptive statistics. It says it consists of the collection, organization, summarization, and presentation of data, but then it says, okay, in descriptive stats, the statistician tries to, well, looky there, describe a situation. Okay, descriptive stats, we're describing. But then at the top of page 4, it says, well, here's this other one. There's another area, and it's called inferential statistics, and it consists of generalizing from samples to population, generalizing, performing estimations, and this hypothesis test, determining relationships among variables, and making predictions. So here, the statistician tries to make inferences. They're going to infer. They're not just going to describe, they're going to start making inferences. And if you go back to page 362, it says one aspect of this is estimation, which is the process of estimating the value of a parameter from information based on a sample. So we're going to look at a sample and try to talk about the population. For example, and I'll read a few of these, the average amount employees and employers pay for health insurance is this. How do they know? They said it's the average, and it's the United States of America. It says if for people who were asked if they won $5,000 tomorrow, 54% of them said they would pay off their debts. How do we know? 80% of the people surveyed in the U.S. said they participate in skiing in the wintertime. What people who participated? Consumers spend an average of $126 for Valentine's Day. This one, the average amount spent by a TV Super Bowl viewer is. How do they know? And so I want to go to this paragraph right here. The statistical procedures for estimating. Estimating. How do they know this about the population? The mean, the proportion, the variance, and the standard deviation. That's what's going to be explained in this chapter. But for right now, we're just building, which just is a underestimated word. We're building a foundation. So you see that in 7.1, we're talking about confidence intervals. The main objective of this section is to explain the basics of estimating what is going on with the population. Like what's the mean, what's the proportion, what's the variance. I underlined the S's and I underlined the P's. Sample goes with a statistic. Sample measures, like a statistic, are used to estimate the population measures, the parameters. For example, a sample mean is used to estimate a population's mean, its average. A sample proportion is used to estimate a population proportion, and these statistics are called, well, makes sense, estimators. Top of page 363. It says there is this thing called a point estimate. And on this point estimate, it is a specific numerical value estimate of the parameter, the population. The best point estimate of the population mean is the sample mean. Okay. The best population estimate is the sample mean. Okay, as stated in Chapter 6, the sample mean will be, for the most part, somewhat different from the population mean because it was a sample, and there's going to be error just because it was a sample. Therefore, you might ask a second question, well then how good is this point estimate? Well, already got a smiley face. The answer is that there is no way of knowing how close a particular point estimate is to the actual population mean. Oh my gosh. This answer creates some doubt about the accuracy of point estimates, and for this reason, statisticians prefer another type, not just one point, but an interval, a from here to a there, a lower number to an upper number. The interval estimate of a parameter is an interval. It's a range, a lower number and an upper number of values used to estimate the population. This estimate, again, this estimate may or may not contain the value of the parameter being estimated. That's why I did a little shock face. Well, wow, we're going to do all of this work and we still may not have everything we were looking for. So in an interval estimate, the parameter is specified as being between. Again, we're building a foundation on what we're about to be doing, but this is a great time to start and stop your video. What has been said and what do I need to understand? And have I soaked in? And do I really get everything that's going on here? So for example, an interval estimate for the average age of all students might be, and we read from the middle, mu is less than 22 7/10, and mu is greater than 21 9/10 years. But this is the one I want to play with. 22 3/10 being like the middle, plus or minus 4/10 of a year. And some of y'all may see this on advertisements for land for sale. It may say 30 acres, plus or minus 5 acres. Give or take, from here to there. And so I put this little piece of paper together for us. Let me put it over here. That if we did put this 22 3/10 kind of in the middle, and if we did add 4/10 to it, it would give us a top number of our range. And if we did